Okay, we are starting off on page 83 with 4.3. Here we go. Using scientific notation to describe very small quantities. Your friend says a zeptometer is 1 times 10 to the negative 21st, based on its standard form. Explain your friend's zepto reasoning. Is your friend thinking more science or fiction? So here we have a little chart, and here's a zeptometer. We have meter, decimeter, centimeter, millimeter, and now we have a zeptometer. And we know how we want to write this. We know it's going to be 1 times 10. Now we just need to know what our exponent is. So how we do this is we start here and we count over. And these are really small. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. This is to the negative 21st power. And your friend did say that it would be to the negative 21st power. So our friend is correct. He's very scientific. It's more science because he is correct. Now down here, does it make more sense to use scientific notation or standard form to represent 1 zeptometer? Well, obviously scientific notation. Why? Because it's a lot easier to write. It's a lot easier to write if we are using standard notation. All those zeros, look, there's 21 zeros right in a row. It's easy to make an error with all those zeros. All right, so now we're on page 84. We're going to do the got it. An X-ray can have a wavelength of 0.00000, all these zeros, 1 meters. Express this wavelength in scientific notation. So again, how we do that is we count 1, 2, 3, 4, 5, 6, 7, 8. And we get it until we have a number more than 1 but less than 10. So we know it's 8. So that's going to be times 10. 1 times 10 to the negative 8th. So I did my exponent first because I didn't want to forget. So I knew it was going to be negative 8, and we know it's 1 times 10 to the negative 8th. We're going to skip this problem. So I want you to try the U-try. It's on page 86. We're going to do number 1. The diameter of an average, well, actually, why don't you pause here and tell me what you get. See if you get it right. Okay, and our correct answer, you should have moved your decimal over 4 times to give you 3.937 times 10 to the negative 4th. And of course, we do want to write our units, and our unit is in inches for this. So let's move on. Page 85. Express the diameter of a red blood cell shown in the standard form. Well, there's your red blood cell. I know it looks kind of creepy, but here is, and I'll switch colors. Here is our scientific notation that they want us to write it out in standard form. So how we do this is we take our decimal and we want to go 6 spaces and we're going to go to the left. So 1, 2, 3, 4, 5. Oh, and I ran out of room. Let's go. So 1, 2, 3, 4, 5, and 6. And that's where our new location of our decimal will be. How many zeros do we have to fill in? 1, 2, 3, 4, 5. So it's going to be 0.007 times, or no, 0.007 meters. Okay, now the U try. Page 86. The diameters of an atom can vary. One particular atom has a diameter of 5.0 times 10 to the negative 8th. Express the diameter of the atom in standard form. So go ahead and pause here, see if you can get it right. Okay, and it says the diameter, or the diameter, once we move our decimal over 8 spaces, is going to give us this big long number. How many zeros are there? There's 7 zeros there. So make sure you have 7 zeros, then 5, and then of course we want our centimeter. Oh, our centimeters, not our meters. So make sure you use centimeters. All right, let's flip back to page 85. The length of a cell A is 3 times 10 to the negative fourth. So A is 3 times 10 to the negative fourth. B is 3 times 10 to the negative fifth. How much longer is cell A than cell B? All right, and I'm going to get rid of this for now. So let's express both of these in standard form. So here we want to move our decimal from being here over 4 spaces. So 0.003 meters. And this one, again, is going over 5 spaces, 0.00003 meters. So we know cell A is bigger because there's less zeros than cell B. Well, here there's 3 zeros, here there's 4 zeros, and a general rule, as long as it's exactly the same, a general rule is each of one of these places equals 10 times more. So here we have 4 places. Here we have 3 over here. So we know that cell A is 10 times longer than cell B because it has 1 less place. So cell A is 10 times longer than cell B because it has 1 less zero, 1 less place. Okay, so we're actually going to skip this U try down here. And I want you to go ahead and get started on your homework. It is 4-4 on digits.